Hello everyone. Today we are going to discuss the path existence queries in graph, right? And let's read the question. So we are given an integer which represents the number of nodes leveled from 0 to n minus 1. And we have also given an array nums of length n, and it is sorted in non-decreasing order. And we have also given an integer max div, right? And since what are the edges of graph? Edge is undirected, and there is a edge between I to j if the difference if it satisfies this condition that nums I minus num j is less than equal to max d. And then we have given queries, and we have to tell whether there is a path exist between node u and v, right? And for each query, we have to return the answer. So what we have given to solve any question, we have to first look out at the questions and find out the key elements of the question what is given. So let's see what are the key elements. We have given n nodes, right? Level from 1 to n minus 1, right? Second point is we have given array nums, and nums is sorted, right? And for the graph, the edges are having condition that nums I minus nums j should be less than equal to max diff, right? And that's much. And fourth is we have to query we have given u and v, and we have to check that there is a path between u and v or not. So we have to answer these queries, right? So first of all, in the queries questions, right, where you have to ask the queries. So in 90 of the cases, you have to pre-process the array, pre-process the things, so that you can answer the query in O of 1 or log n in the most of the questions, right? And we will do the same. So since we have to check that u and v, there is a path between them or not. When in a graph there is a path between node A, B, suppose this is a graph, right? And suppose this is a graph, right? So does there is a path between A and C? Yes, it is, right? ABC. Does there is path between A to E? There is no path. There is a path between D to E? There is a path. So we see that if the graphs are connected, right? If the graph belongs to the same group, if they are connected, there will be always a path, right? There will be always a path if it is connected, right? So the problem boils down to we have to just check that u and v they belong to the same component, right? I mean same group, right? Since and so how to find the components, right? One way is DSU, but DSU is has a lot of code, right? So we will not go. We have given other things also. We have given this point, right? The age. There is no randomness. If there was randomness, we have to go with the DSU to check the components, right? If two nodes belong to the same component, means same group or not. So ages are there is a pattern in age, right? So nums I and nums j should be less than equal to max if then only. So if let's see the example, right? So if you see here, so does two and five is connected? So max diff is 3. So 2 and 5 is not connected, right? If difference is 3, but max diff is only 2. But does this is connected 5 and 6? Yes, the difference is 1, so this is connected. Does 2 and 6 is connected? No, because difference is 4, right? So guys, if you observe this point, right? Since if 2 and 5 is not connected, so this node can will not have any edge because it is sorted, right? If the minimum difference between two will be the adjacent one, right? So if 2 is not connected to 5, 2 cannot be connected to any of the elements after that. So can we say that the group of 2 finishes after this and there is a new group will start, right? So 5 and 6 difference is 1, then 6 and 8 difference is 2, so it will be connected. So did you guys observe the pattern that if it is not connected, so it's a breakage, a new component will start. When it will start, uh, if the difference is less than 2, till the difference is less than 2, so it will connected to this, it will connected to, there is a difference is 3, but it is indirectly connected because this is connected to this is connected. So we just have to find out. The problem boils down to we just have to find out. So starting from ith node till what node we can continuously the difference is less than max diff, right? Just we have to check that, right? So what we can do? We can make a variable group, right? We will number this group, right? So we will make the variable to right group and we will give the number. So initially it will be group 1. So and if the max diff is not less than equal to max diff, right? If the difference is not equal to max diff, then we will do nothing. We will increase the group because there will be a new group starting from here, right? And if it is same, so we will just give same ID and we can store this, right? And we can, how we'll check if 5 is connected to 8 or not? We'll just check what is the group ID of this. This is 2. And what is group ID of 8? This is 2. So the group ID is same, they are belongs to the same group. That means there is always a path from U to B, right? So this is a very simple method to solve this problem, right? So let's go and summarize this, right? So what we are going to do first, since nouns is already sorted, we will uh, take a current group, right, as one, and we will number. So we will start from, we will take a group ID array, right? Group ID array, right? And from here, what we will do, we will just store the group that index belongs to, right? So we'll traverse and there will two condition. If the difference is less than equal to max, we'll continue. If it is greater than max, we will increase the group ID, right? So there will be a new group starting. So there is pretty simple code for this, right? So let's go and see the code, right? So code is very simple. We are taking a group vector. We will store the that group that node is belongs to, and how we are assigning uh, the ID of the group. We start from group ID as one, and initially the first node we assign it to ID1, right? And we just check that if this number, if this number and its previous is difference is less than max div, then we assign that means that this group ID belongs to the previous group group node, right? So it will assign that, and if that is not the case, then there will be a new group after that. So we are adding +1 to the previous, that start a new group, right? And for the each query, we are taking an answer variable to store our answer, and we are just checking that if both the u and v belongs to the same group, then answer will be yes, and if it not belongs to the same group, answer will no, right? So this is pretty simple question, right? And since this is part one, it may comes as a part two, right? As tomorrow. So the part two is the part two is belongs to, suppose if it is not given sorted, right? And we have to determine the part two question I will show you. So in part two, we'll discuss tomorrow. If you should go and check, that is a very pretty question, and that's uh, uses the binary lifting, very good concept of binary lifting, right? You should check. Let me show you the question, right? So, so this is a question, right? And it is saying that the question is same, right? And since it is now this is array is not given sorted, so we know that for this condition, grouping becomes very easy if we sort this, right? At previous we group them, and now it is we have to find the minimum distance, right, between u and v. So there is a very good trick that is called binary lifting, which tells from in how many if you go have to go from this node to this node, right? So if you walk from this node, if you walk uh, to a step, where you will reach, so this one or this one, right? And but that works only when the graph is functional, which means that there can be at most one outgoing edge. So it is three edges, right? So this is not a function graph, so you cannot directly apply. So you can do an observation that after sorting this, if you are able to reach at node, if it is given as zero, like if it is given like 1 2 3 4, right? And and you have to check if you are able to uh, reach at uh, 3 or not, right? And the max diff is 3, right? So you know that from this node you can easily reach up to 3, right? So why not you store that in one step, you can go at max 5. So if you are able to reach 5, you will always able to reach all the nodes which is greater than 2, right? And less than 5, right? Node is less than equal to 5 in one step, right? So if the array we extend the array, Now you know that from 5 you can go up to the max and up to 8, right? If max difference is 3 up to 8. So if you ask, I ask you what is how many minimum number of step you can reach from 2 to 8. There is no point going to 3, right? Because that will increase the number of steps. So we go at max, we go to 5, and in 5 we go to 8, and the number of steps we take is that is 2, right? So that is the very simple trick, right? And since you have to uh, suppose it asks me 2 to 7. So since in second step we are able to reach at 7, so we know that in second step we can go here as well, right? Because that is the maximum. If we can go here, so if we we can easily took less step to reach here. So we only check in the case step. In the case step, can we reach to that is less than that the next node, right? If if it is if target is less than equal to that next node, then we reach at the in the kth step. Since we have to go from in one step, you go to the next node, and from here you go to the next node. Then from here you have to go to the next node. So for this, and if you observe this graph, initially from one you can go up to many uh, nodes, but since you are following the step you can take, so there will be only one node where you can reach, right? And from here you can only reach to one node, right? So it finally converted to the function graph, that is at max one outgoing edge is there, right? And here you can easily apply binary lifting. Binary lifting is nothing but you pre-calculate that if you take uh, to the power 0 in the power of 0, right? As we do in a sparse table, right? So that because why binary? Because if k can be any number, that can be represented as binary, right? So and so if we go ahead to 5, right, and binary of 5 is 1 1 0 1, right? So you can go 4 steps from here and then take one step from here, right? So in 5 step, how which node you will reach, you can easily calculate, right? So it's pretty simple uh, to calculate that, right? Uh, it's the binary lifting is a very interesting topic. You go and search for binary lifting, right? Uh, it's very good concept in the graph. If you see that in range queries in array, right? For the range queries in the array, we use segment tree, right? So in the graph and tree for the range problem, the binary lifting is the act as same as giving the as segment tree, but difference is just is that uh, it's not actually segment tree because segment tree also use if the range is updated, but here range should be static, right? So that graph should not be updated. So segment tree you can think of is like a sparse table. Actually, a sparse table is exactly same, and we use a sparse table logic here to build our binary lifting. So you can think of a sparse table that will be most related to this one. So go and explore and try this question, right? So that's all for today. Enjoy.